Conditional probability. That's when you compute whether something has happened given that something else has happened. In other words, like if a die is rolled, the probability that a 5 occurs given that an odd number is rolled. So in other words, you already know that the number was odd, but what's the probability of that odd number being a 5? So we'll remember that, when you roll a dice, it's 1 through 6. The odds are 1, 3, and 5. So the event an E occurs, or event E that a 5 occurs, has the probability, so 5 given that it was odd. So the first thing we want to know is, what are the odds of, how many times would you get 5 and an odd number rolled? So the intersection of those two events. Divided by the probability, or the number of ways that an odd number can be rolled. So there's only one way to get a 5 and it being odd, and there's 3 ways to just roll an odd number. So here's the formula for it. You would find the probability of both of them occurring at the same time, divided by the probability of the given. And I'll show it 2 different ways. And I'm going to try different pens to see if it doesn't bleed through as much. Suppose the following table summarizes the opinions of various groups in a survey on immigration laws. What is the probability that a person selected at random from this group, first off, is non-white? Okay, so the probability of non-white, and I'll just put a W for white. How many people were non-white? Well, so there's 50 Republicans and 200 Democrats, so that's just 250 out of 1,000. Then what's the probability that somebody is non-white and favors the enforcement of immigration laws? So probability of non-white and favors. Okay, so how many people are in that group? So we're going to look at the favored row, and that would be 25 plus 10. That's 35 out of the 1,000. Favors the enforcement, given that we already know the person is non-white. So this is the probability of favor, given that we already know they're non-white. So what we'll do is use the probability that it's both favor and. So probability of favor and non-white divided by the probability of the given, so this is the underneath part, non-white. So and was the 35 out of 1,000, right? Divided by the 250 out of 1,000. Well, the 1,000s can kind of cancel, and I just end up with 35 out of 250. What's really happening here, if you think about it, is we're narrowing down our sample. Instead of looking at the whole box, I'm only looking at this box. So there's 35 that favor out of the 250 total that are non-whites. So you're really just shrinking down your sample size, is the way I like to think about it. Let's say a red die and a green die are rolled. What is the probability that the sum rolled on the dice is 6, given that the sum is less than 7? So the probability of the sum is 6, given that the sum is less than 7. So I'm going to go back in our notes to page 9. So what we need to have is the probability of the sum is 6 or the sum, or and less than 7 divided by the probability the sum is less than 7. So in this case, this really is just the probability the sum is 6 because 1, 2, 3, 4, 5. There's 5 ways for that can happen. That's going to be 5 out of the 36 ways. The sum is less than 7, so we'd have 6 plus 5 plus 4 plus 3 plus 2 plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, less than 7, so not including this row. 2, 3, 4, 5, so that's 15 of them. So we end up with 5 out of 15, or 1/3. Now, sometimes we talk about 2 events happening. So 2 different events, the probability of A and B happening. So this is when you have something happen and then something follows it. Suppose that, and the easiest way to really think about this is not using the formulas. Okay. So suppose that a deck of 52 cards, 2 cards are drawn in succession without replacement. Find the probability that both cards are kings. So when I first go to draw the cards, let's think about this. The probability, the first is a king. Well, how many kings are in a deck of cards? Well, if you didn't know, it's 4 out of 52. The probability that the second is a king, given that the first is a king. Well, let's think about that. If you already drew a king, then the second card being a king, there's only 3 left out of how many? Out of 51 left. And when it's an and situation like this, we're going to multiply those 2 probabilities together. So the probability of 2 kings is going to be that 4 out of 52 times 3 out of 51. And I don't know what that is off the top of my head. I would use a calculator. So I'm going to go in here and I'm going to do a fraction. 4 out of 52 times fraction 3 out of 51. And it gives me 1 out of 221. Now we can also represent these outcomes with what is called a probability tree. So this is the same situation. So the first draw, to get a king, there's 4 out of 52. To get a not king, it's 48 out of 52 because there's 48 that are not kings. When I draw again, there's only 3 out of 51 cards that are kings. And not kings would be 48 out of 51. See how that works? Now, if we didn't draw a king on the first round, we drew a different card, then there's still 4 kings left, and so forth. So we can see these branches, and a lot of times these branches help us see these compound situations. And we would just multiply the branches together following whichever branch we need. Let's see that in action. Well, we don't actually have to draw a probability tree, I don't think. But we will. Okay. So a box contains 3 black balls, 2 red balls, and 5 white balls. 1 ball is drawn and is not replaced, and then a second one is drawn. Find the probability that the first ball is red and the second ball is black. Okay, so on the first draw, how many different options could we get? Well, we could either get the black ball, the red ball, or the white ball. What's the probability of drawing a black one? Well, that's 3 out of 10. What's the probability of getting a red? 2 out of 10. And the white is 5 out of 10. Now, on the second draw, we have 3 chances off of each of them. So, 1, 2, 3, black, red, or white. Black, red, or white. Black, red, or white. Okay, so if the first draw we drew a black ball, what's the probability of getting a black ball in the second draw? Well, I've already got 1. So this would be 2 out of how many are left? 9. If the first one I drew was black, how many red ones are there? Well, there'll still be 2 red ones and 9 total. If the first one I drew is black, then I'm going to have 5 white ones and 9 remaining. If the first ball I draw is red, then there's still 3 black ones. There's only 1 red one, and there's still 5 white ones. If the first one I draw is white, then there's still 3 black. There's still 2 red, but now there's only 4 white. Now we want the first ball to be red, so this path, and the second one to be black, so this path. So that would be the probability of the first is red and the second is black. Would be following that path. It would be taking 2 out of 10 red and then 3 out of 9 black. That leaves me with 6 out of 90, which is 1 out of 15. Now let's see this in a little bit of a different setting. Delinquent accounts. Ooh. Polk's department store has observed that 80% of its charge accounts have men's names on them, and that 16% of the accounts with men's names on them have been delinquent at least once, while 5% of the accounts with women's names on them have been delinquent at least once. What is the probability that an account selected at random meets these conditions? So first off, let's see how this would work. So let's do a diagram. So when I pull a charge account, it's either going to be a man or a woman, right? The probability of it being a man is 80% or 0.80. So the probability of it being a woman is 0.20. Then we're looking at whether it's delinquent or not. So let's see, let's call this delinquent or okay. Delinquent or okay. If we know it's a man, what's the percentage of men that are delinquent? Well, that's 16%. So 84% would be okay. What about the women? So it says 5% are delinquent. So that means 95% are okay. So the probability it's a man and it's delinquent. So it's delinquent given that it was a man is following this path, 80% and 16%. So that's 8.80 times 0.16. And we get 0.128. What is the probability it's a woman and is a delinquent? So 0.20, and delinquent was 0.05. So the probability is 0.01. A manufacturing inspection. So all products on the assembly line must pass 2 inspections. It's been determined that the probability that the first inspector will miss a defective item is 0.09. If the item gets past the first inspector, the probability the second inspector will not detect it is 0.01. So the probability that a defective item will not be rejected, so it passes both. So the probability it passes both. What's the probability that it passes the first guy, that he misses it? Well, it's 0.09. What's the probability that the second inspector does not detect it? It's 0.01. So the probability that both of them miss that defective item is 0.0009. It's really, really low.